Okay, we're going to do 1/6 B and C today. It's kind of a lot, but it is blocked, so there you go. 1/6 B and C. We're still talking about our additional topics in Trig. I'll just go ahead and label it Trig. So these are the Trig topics that we're going to do. Are you ready? Okay. We're going to do inverse trig. That's always a tricky one. That's a tough one for a lot of people. Then we're going to do graphs of trig functions. Okay? We're going to talk about shifting and domain range. And then we're going to do some just practice problems, and that'll be it. Okay, so here we go. Letter A. Let's start with inverse trig. So I hope by now, if I ask you, bless you, the sine of pi over 3, I hope that you would be able to tell me what the sine of pi over 3 is, right? You might need to quickly sketch a unit circle, but you know where pi over 3 is. It's up here. It's 1/3 of a pi. And that this is the point 1/2 rad 3 over 2. And so what's the answer to this? Rad 3 over 2. Perfect. Okay. Now we're going to go backwards. I'm going to say sine of some angle gives me rad 3 over 2. And this is not a function because if I was on the unit circle, let's say I'm just on 2 pi, 0, 2 pi, I would get two answers for this. I would get an answer in quadrant 1, and I would also get an answer in quadrant 2. Okay? So for sine inverse problems, we have to restrict our domain so that we only get one answer. Does that make sense? Yeah? Okay? Because in order to be a function, an input goes in and only one output can come out for it, not two. I can't get two answers for this. So that's when sine inverse showed up. So here it is. Mrs. Brandehorst is creating assignments for my son. Do you see that? Oh, a lot of them. Is that what happens when I create assignments? Yeah? Okay. So now we have sine inverse, and let me just walk through how you're going to find where your answers come from. Okay? So let's say you have the sine inverse of x. Sine inverse of x. The domain of this, the answers that are going to come out of this are going to be from negative pi over 2 to pi over 2. It's been restricted. It's kind of like if I ask you, hey, pick a number between 0 and 10, and you tell me 20. You're automatically wrong. Okay? So they're telling you that your answers have to only come from this area. Well, what is that area? That area is negative pi over 2 to pi over 2. It's this right here. It's quadrant 1. They're going to give me all of the answers that have a positive value. And quadrant 4, all of the answers that have a negative value. And the other thing that you have to be careful of is that when you give me this answer, it's either going to be from 0 to pi over 2 this way, or it's going to be a negative angle going that way. Do you remember these a little bit? Okay, so let's go ahead and try some. So for example, number 1, and we'll just do a bunch. So let's find the sine inverse of 1/2. Sine inverse of 1/2. What that's asking you to do is it's asking you find the angle that gives me a sine value of 1/2. Okay? So what angle would that be? Are you pretty comfortable with these? It would be pi over 6. Perfect. Because we just did rad 3 over 2, so you know that this would be pi over 6. Okay. Now if, let's call that 1a. If I decided, okay, I want to find the sine inverse of negative 1/2. Sine inverse is actually pretty easy because the answer is just going to be pi over 6, but negative. And that's your answer. Now do not tell me that the answer is 7 pi over 6 or go around over to, what is that? 11 pi? No. Gosh, I haven't done these in a long time. Is that 11 pi over 6? Yeah. Wow, I'm a little rusty on my trig. Okay, let's, and then let's try another one. A, B, C. Let's do sine inverse of negative rad 2 over 2. Sine inverse of negative rad 2 over 2. What would that one be? It would be negative pi over 4. Perfect. Okay. We're not going to do the real tricky ones, just basics. Because remember when we did the sine inverse of the cosine of something, and yes, the compositions, we did those. All right, so that's sine inverse. Now let's talk about cosine inverse. Cosine inverse is going to have a totally different domain of numbers. Bless you. It's going to include quadrant 1, but it can't include quadrant 4, because in quadrant 1, cosine is positive, and in quadrant 4, cosine is positive. We don't want two answers coming out of this. So we're going to use quadrants 1 and 2 only. Okay? So your answers are going to come from 0 to pi for cosine inverse. So those are going to be your positive answers, and quadrant 2 will give you, well, not your positive answers, but when you're taking it of a positive number, you will get an answer in quadrant 1. If you are doing it of a negative number, you'll be in quadrant 2. So let's see how that works. Number 2. Let's find the cosine inverse of 1/2 first. Cosine inverse of 1/2. So in other words, what angle in quadrant 1, because this is positive, this 1/2 is positive, what angle gives me a cosine value of 1/2? You got that? Pi over 3. You're pretty quick on these. You got to be pretty quick. It's nice to have the unit circle in front of you, right? But I can just picture it, imagine it. Okay, so what would then be the cosine inverse of negative 1/2? It's not going to be negative pi over 3. That would give you a positive 2 pi over 3. Yes. So we're in quadrant 2. It's still the pi over 3 reference angle, but it's in quadrant 2. So it's 2 pi over 3. Okay, you remember these? Pretty good? Yeah. What's the cosine inverse of negative 1? Yeah, I know. Yeah? Pi. Okay, over here, this right here on the unit circle, I forgot. Oh, hold on. So yeah, I'm sorry, what I was saying was right here, this is the point negative 1, 0, okay, on the unit circle, and so this angle is pi. Now remember, your answers, see there's a bracket around 0 and pi because those are okay. You're allowed to have them. But do not go past it. Don't go the other direction. Any of those answers will not work. All right, and finally, the last one of the inverse trig functions is tan inverse. And tan inverse is a lot like sine inverse. They're going to share the same numbers. By the way, these are also called like arctan or arcsine, arccosine. You remember the arc? Yeah. But a lot of times we just write tan inverse. They were hard, huh? Do you remember those from last year? I know. Okay, so for these, same thing as sine. You can go this way. This is when your value of x in here is positive in quadrant 1. Or you can go this way, and that's when your answer or your number on the inside is negative, and you'll get a negative angle. These are a little bit harder, though. Do you remember these? So, like, if we had tan inverse of rad 3 over 3. Tan inverse of rad 3 over 3. So there's really two of them. There's tan inverse of rad 3 over 3, and there's tan inverse of rad 3. Okay, some people memorize these. Some people don't. This one was, you remember what this one was? It was pi over 6 because the 3's add up to 6. Remember someone said that? And this one was pi over 3 because it's just 3.
We just have to remember those two?
Yep.
And then the other one is 1.
Yeah. So this one is 3 pi over 2 over 1/2. See, that's when, so tangent is sine over cosine, or y over x. And when you flip that, you will get rad 3, which is this is the angle at pi over 3. And if you flip them, you'll get rad 3 over 3, which is at pi over 6. Yeah, and then tan inverse, let's do tan inverse of negative 1. If I'm trying to find out where tangent is negative 1, okay, where's tangent positive 1? Tangent inverse of 1 is where the sine and cosine are equal to each other. Where's that spot at? Pi over 4. So the answer to this one would be negative pi over 4. Yep, because on the unit circle at pi over 4, that is the point rad 2 over 2, rad 2 over 2. And when you divide that, you get 1. So if I asked you what's the tangent of pi over 4, you should know that that's 1. So if I go backwards and do what's the tan inverse of 1, the answer is pi over 4. Okay? All right, that was a tough stuff all in one little thing, so be prepared for that. Let's move on. By the way, your calculator also knows how to do these.
Oh, I know, this is bad.
Let me show you real quick. Part 2. 3, I think.
For B and C?
Yeah.
Okay, great.
We're going to do some graphs now. Graphs of trig functions. Okay, we're going to do a lot of these on our calculator, which is weird because last year, I know in my class, I wouldn't let you use your calculator to graph any of these. But you should be able to do both, like graph by hand and on your calculator. So let's go ahead and let's just graph y equals sine of x.
But we'll be able to use our calculator.
Yeah. Yeah. Okay, and when you graph y equals sine x, make sure that some things happen. Make sure that you're in radians. Okay, I just changed to degrees, so I need to change back to radians. When you graph this, don't hit zoom 6. You know what you should go to? Zoom Trig. There's a zoom Trig feature. It's really nice. It actually makes a different window if you have an older calculator, if you have a newer calculator. So make sure that you're in radian mode, function mode, y equals. So we're just going to graph basic sine of x. What's that one up there? That's sine x up there on that graphing calculator. And I'm going to go zoom number 7. Zoom 7 is zoom Trig. And you get a really nice graph. Okay? And then if you want to, you can look at the window, see what window they made for you. In zoom Trig, my calculator does negative 6.15 to 6.15. What do you think that's approximately?
2 pi.
About 2 pi. And then 4 to negative 4. So there you go. And you can trace this if you want to plug in pi over 2. You can see that it equals 1 there, stuff like that. It's pretty good. Okay. So let's talk about the domain and range of our trig functions. So sine's always been my favorite. Do you remember graphing it with me? And I went like this. I went 1, 2, 3, 4, and this was 2 pi. And in the middle is pi. And then we start at 0, and then we go up to 1, back to 0, down to negative 1, back to 0. I did that pretty quickly, huh? There you go. So that's just the basic sine, and if you look on your calculator, you can see that. If you go to the table of values, it'll show you all those table of values. So let's talk about domain and range. What's the domain of this function? All real numbers. Yeah, so the domain, you were thinking range. Domain is all real numbers. All the x's. Is this graph ever not continuous? No, it's continuous forever. There's no breaks. There's no weird stuff going on. The range is, yes, negative 1 to 1. Okay, for a basic trig graph. The period of this graph, period means that it's going to start over again and do the same stuff. The period is 2 pi. Perfect. We're really going to focus on just the graphs of sine and cosine, not so much tangent or cotangent, or really the other ones. All right, so now we're going to do some transformations of these graphs. Okay, so I'm going to give you this crazy thing. Here it comes. Transformations. This is going to be a crazy little formula for you, but it's going to show you all the stuff that happens. So if you have y equals a, okay, and then you have your function, whether it's sine or cosine. I'm just going to write sine for right now. Okay, that could be cosine. And then you have bracket b, parentheses x plus c, and then plus D on the outside. Okay? There's a lot of things that we can do to this graph. So let's talk about all these things. So A is the vertical stretch or shrink. If A is negative, we reflect over the x-axis. The absolute value of A is called, do you remember what that was called? Starts with an A. No? Amplitude. Yeah, amplitude. Amplitude is basically how high or how low it goes through your symmetric horizontal axis. Okay, B is going to tell you the horizontal stretch or shrink, but we usually do this as B is usually 2 pi over B is the period. So that's going to shrink it or make it go bigger, your wave. C is going to be your shift horizontally. Horizontally. Okay, and you always go the opposite direction. And then finally, that letter D on the outside is your vertical shift. And that one goes up or down depending on, oops, sorry, let's just fell apart. Up or down if it's positive. Positive, it goes up, and negative, it goes down. And that's true for really any functions. All those functions have the same shifting stuff. Okay, so let's do one. Are you ready? Yes, you are. All right, I don't even know what number. I haven't even really been labeled these. I'm going to call this number 3, just because that sounds great. Number 3. Y equals 3 sine of 2 times x minus pi over 2 plus 1. Okay, when I taught this to you, or when Mrs. Pfeiffer taught this to you last year, we took things one step at a time. Today, I threw it all at you. Because you know how to do this, right? So let's talk about all this stuff. So here we go. First of all, the amplitude is 3. The period of this graph is 2 pi over 2. So it's just pi. So that means that instead of the whole thing happening in 2 pi, the whole thing happens in just pi. Okay? Shrinks it in. And let's go ahead and we're going to shift this pi over 2 to the right. And 1 up. All right, so let's do it. We're going to graph this by hand, and then we'll check it on our calculator to see if it's right. Here we go. So draw your graph, and this is what I like to do. If I ever have a shift up or down, I like to go ahead and make this the new x-axis. There's no asymptote there. That is not an asymptote. That's just there to help me know that that's where my zeros are going to go. Okay? And then from here, my amplitude is 3. So I know that I'm going to go 1, 2, 3 up, and 1, 2, 3 down. Okay, I also know that the period is pi. So for me, what I like to do is this. I go 1, 2, 3, 4, and I label that as whatever the period is. So that's pi. In the middle is pi over 2. And I only require you to do 1 period for cosine, okay? Just 1. All right, now, here we go. I'm going to put a red dot on where I normally would start my sine graph, which would be right here, okay, at 0, 0. And I do that in quotations because that's not really 0, 0. But I need to shift this thing pi over 2 to the right. So I got to go that way. So I'm going to take this, and this right here, I'm going to draw it in blue, is part of my graph. That's my first point that I have for my graph. Okay. Now the next tick mark that I have right here in black, I'm going to go up to the tallest peak. 1, 2, 3. 3 above that one. Then I'm going to go to my next tick mark, and I'm back on the green line. Okay? I need some more tick marks going this way. So then my next point would be to go 3 below, 1, 2, 3, on my next tick mark. And then my next tick mark, I'm back at green. So you're green, you go up, and you go back to green, you go down, and you go back to green. And then now we're ready. And you can draw some more this way too. If you wanted to, you would be here, and you would be there. Pretty fun, huh? I really like doing these. I'm looking forward to second semester. So let's go ahead and graph this then on our calculator and see if we're right. 3 sine 2, don't forget to put a parenthesis there, x minus pi over 2, close that parenthesis, close the other one, plus 1. I already have zoomed trig. Does it go through 0, 0? Did I mess up? No. It goes through there. I did it right. Yay. Phew, I was a little worried. Now, if I wanted to check, like this one right here is pi over 2, I can hit trace and plug in pi over 2, and that will give me that y is 1. And that was that first point that I started with right there. All right. Let's do another one. Let's do a cosine. We haven't done a cosine yet. Number 4. Ooh, I'm sorry. Let's go back to this problem real quick. I also could ask you for the domain and range of this function, which I might. Domain and range, this just always stays with us. The domain's easy for sine and cosine. It's always going to be all real numbers forever, okay? And then just look at the graph for the range. How low does it go? -2. How high does it go? 4? So -2 to 4. Perfect. So -2 right here, that's as low as it goes. And then up here at 3. 4. Because it's 3 above 1. Because we shifted it up 1, and it's 3 above that. All right. Good talk. Here we go. Number 4. Y equals. Ooh. Let's go with -2 cosine of 2x plus pi minus 3. I just made that one up. Alrighty, a couple of things here. First of all, amplitude is never negative. So if they ask for the amplitude would be +2. Okay? It's the absolute value of A. Now the shift is a little tricky here. Well, let's do the period. The period is 2 pi over b, which is pi. So the period's pi, and the shift is not pi. Okay? Yes. It's not pi because this shift right here is shifting on 2x. We need the shift on x. So what we do to fix that is we can factor out a 2. So you get 2 times x plus, you're dividing out a 2, and that's what you get. That's why when I gave you that formula, you see that formula? This b is factored out of there. Has to be factored out of there. Okay, I gave you this one. It was already factored out, but this one I didn't. So I will have a lot of people, like Gregorios, who's not listening at all today to me, and he will say the shift is pi to the left on his next quiz. I guarantee it. Nope, you're not going to. Okay, good. All right, so what is the shift then? Pi over 2 to the left. Good. And then down 3. All right, are you ready? Let's graph it. Now, you do get your calculator. You do. Would you like to try and graph it from your calculator, or would you rather graph it by hand? Yeah, calculator. There's a lot of calculator lovers out there. Let's try it. Let's do it on here, and then but then you're going to have to plot some points.
Wait, so we don't have to do this on
Right. You get your calculator for the whole thing.
Wait, so we don't have to do this ever?
Right.
Oh, yeah.
No, because it's so good. I like doing these by hand. And teachers, we like to teach you the things we like. All right, here we go. 2x plus pi. But you like to do the easy way, right?
Yeah.
Which is calculator.
Yeah.
Okay, let's do that. And then I'll show you how to get some good points on this graph, okay? So let's go ahead and graph. Ooh, it dips way low. Now, it looks like it's not continuous, but that's just because my window on my calculator isn't far enough for the negative. So I'm going to go to -6, and now I'll get the whole graph. Okay, so here's a good way to graph this. Now, we do know that we are shifting this thing down 3. Okay, so I can put my imaginary horizontal line there. And so what I can do is just go ahead and pick some points. Hit trace, plug in 0, and y is -1. This one is? Graphing on your calculator? It's so easy, huh? Oh, okay. And then pick pi over 2. So you're on trace, and you go pi divided by 2, and you get -5. So let's go 1, 2, 3, 4. Oh, right. So that's pi over 2. Yeah. When do we get 3? Is that pi over 4? Pi over 4, we get -3. So I kind of forgot that one. So this is pi over 4. This is pi over 2 here. And this is pi over here. Okay. So at pi over 4, you're on the green dot. See, I don't even like doing it from here. I get all messed up. And then from here, we're going to go with down 2. And then back to here. You like this? It's slight work. Slight work. Yeah. That's why I don't let the ham kids do it like this. We have to do it by hand. They have to suffer. Yes. Okay, so then from here, from your graph, or just from knowing what these are, what's the domain and what's the range? Of course, I'll give you the domain. That's the easy one. Domain's all real numbers. And then what's the range on this one? How far does it go down? -5 to -1. Perfect. It's in there. Okay, one last topic. Did I say 2? I said 3. One last one. These are going to be some right triangle stuff that we didn't talk about the other day. Right triangles. And I have 2 examples here for you to do. For number 5. Okay, it says here that theta is equal to the sine inverse of 4/5.
So you just plug that in your little calculator, right?
No, it's not asking for that. So it's asking you to find all 6 trig functions of theta. Okay? We did this already. This is just in a different form, okay? What this is saying basically is this. Theta equals sine inverse of 4/5. If you were to do the reciprocal function of sine inverse, which is sine, let's say we take the sine of both sides. Sine of theta equals sine of the sine inverse of 4/5. Okay, what happens is the sine inverse and the sine, they basically cancel each other out because they're inverse functions. Bye, good luck at your golf match. Go low. Fairways and greens. So sine of theta equals 4/5. That's basically what this means, right? We just talked about inverse functions. Sine of what angle gives me 4/5. So now we have a positive 4/5. The sine inverse is positive in quadrant 1. So we're going to draw a right triangle. We're going to label this as theta, figure not drawn to scale. And if the sine of theta is given to us as 4/5, then we're going to do SOHCAHTOA. So sine is opposite over hypotenuse. And there it is again, the old 3, 4, 5 triangle. And so now you can find the rest of them pretty easily, right? We did this yesterday. So if I wanted to find the cosine of theta, that would be 3/5. Or the tangent of theta, 4/3. And all the rest of them, right? Secant of theta is 5/3. Cotangent is 3/4. And then cosecant of theta is 5/4. Okay, I'm very confident in your skills. Just make sure that whatever the number is, if it's positive or negative, you're in the correct quadrant. And then there's one more. Last one, number 6. This one's a little weird sounding, but it says here that there is a point on the terminal side of theta. There's a point on the terminal side of theta. And that point is -8, -13. Thanks, Luke. Wow.
What is that?
Subtraction.
What? D1.
That was from 2 years ago.
You never went and picked it up, so they brought it to you. That's what I'm telling you, everyone. They call you like, go to the office. Don't go. They're just going to bring it to you. They will, eventually. 2 years later, you'll get, that was JV, 2016. That's really funny. All right, here we go. A point on the terminal side of theta. We are going to find the sine of theta, cosine of theta, and tangent of theta. All right, so this sounds super fancy. It's actually not too bad. So write that down. I'll let you catch up. A point on the terminal side of theta is -8, -13. Then we're going to find our 3 trig functions. Okay, so you guys all know how to plot the point, -8, -13. What quadrant are we in? Good. -8, -13. Here's the point. Now that point is on the terminal. You know what terminal means? Like when you go to an airport, they're called terminals because they're going to end your life. Yeah. So terminal means, no? Oh, okay. I don't like to fly. Did you know that? Theta. I'm going to fly in 2 weeks. I'm going to Seattle. I'm sorry, Kevin's not going to be there. Not you, Kevin. My brother, Kevin. All right, so here's theta, terminal side of theta. Now, I can't make a triangle out of this, right? But what I can do is I can make a triangle here. Yep. And then I can use this angle in here, which is theta prime. It's theta's reference angle. Yeah, so if you were to take the tangent of theta, it's going to equal the tangent of theta prime. So then we make a triangle. Isn't that exciting? It really is. And so this becomes, this side here is -8. This is -13, and this is the old 8, 13, 17 triangle. How'd you know that? Oh, it was? Okay. 8, 13, 17 triangle. But make sure you keep them as -8, -13, and the hypotenuse is always positive. Okay, so now we're ready to evaluate. And just SOHCAHTOA again. Sine of theta. So here's theta in here. Sine is opposite over hypotenuse. And aren't we expecting sine to be negative in quadrant 3?
Yeah.
Yes, because all students take calculus. Stop. Cosine would be adjacent over hypotenuse. And finally, tangent is 13/8. Make sure that you get rid of those negatives. Negative over negative is positive. All right.